Welcome back to the Greater Essex County District School Board calendar, where we'll be focusing each month on the fundamentals of mathematics. Each and every month, we'll be diving into a big idea from the Ministry of Education's Focusing on the Fundamentals of Math, a Teacher's Guide document. In particular, we'll be looking at the table that summarizes the curriculum expectations from our current Ontario mathematics curriculum that have always been and will continue to be fundamental for students' understanding and proficiency in mathematics. This month, we'll dive into working with numbers and in particular, place value. So let's begin. In the last video, we explored the importance of the magnitude of number and used linear models like number lines to develop student understanding and flexibility of magnitude. In this video, we're going to look at how we can take this understanding of magnitude from the very spatial relationship we see when we compare quantities on a number line to a more abstract representation of magnitude using digits. Our ability to look at a series of digits and connect their arrangement to a quantity like 1,288 is because of our understanding of place value. When I was in school, I remember just thinking and remembering of the names of each digit, and me personally, I was fine with that. However, there's so much more to understanding place value than simply naming or having students memorize the name of each digit. It's about understanding what those digits represent. In order to understand place value, we need to realize that our base 10 number system is designed to work with our 10 digits, 0 through 9. When we attempt to name the quantity after 9, in this case, 9 squares plus an additional square, a decision had to be made. Either we introduce another symbol to represent that quantity, or we do something with the current symbols we have. So what was decided was that we would unitize or make groups of 9 plus 1 and start counting those as its own unit or grouping. And we would call those groups of 9 plus 1 a special name, 10. If we add one square to the one unit or group of 10, we would then have 1 10 and 1 1. We would use the notation 1, 1 to represent this quantity. Now, unfortunately for students, they're often introduced to this label of 11 using the digits 1 1 before they understand how that quantity came to be named. This forces students to essentially memorize numbers, much like we do when we memorize the alphabet, without understanding. And what makes things even worse is that the names we assign to 110 1 1 and 110 2 1s, what we call 12, is that these names don't give us the slightest hint of the quantities they might represent. With place value, we are able to symbolically represent, using the digits 0 to 9, any possible quantity imaginable. Well, that's actually not quite true, which is why we have other number systems like the imaginary numbers. But that's for us to explore way down the line in mathematics. But for this video, let's look at what happens if I slide my one unit of 10 over into the ones column or the ones zone. I can no longer represent this quantity as 110 and 2 1s. I need to represent this quantity using only single units, the same unit, what we call ones. So let's bust this apart and let's actually go ahead and try to count this quantity. When we do so, we get all the way up to 9 and we run out of digits again. So I could think of this as 9 plus 3 more, or 1 9 plus 1 3, but instead they decided to make 1 more than 9 a quantity we use as a unit. This unit we call 10. Now let's stop and talk about the names of those teen numbers again. We've got 11011, which is called 11. We've got 110 two ones, which we call 12. And then afterwards, we actually have a much better or more predictable pattern here when we look at 13, where teen represents a 10, and thir meaning 3. We have 14, all the way up till 19. And once we have an additional 1 added to that group, we have another scenario where we have 9 plus 1 ones, or a whole 10. And when we have 2 units of 10, we call that 20. And then the pattern continues. 21, 22, and this pattern continues on all the way up until we get to 99, when we have 9 tens and 9 ones, and we add one more 1, we get that 9 plus 1 scenario again, creating another unit of 10. But then look at this again. We have a 9 plus 1 tens, and we have to introduce yet another unit we call 100. And there you have our place value system up to the hundredths column. And we would call this number, this quantity, 100. And if we add 100 plus another 100 ones, you can see the process happen again. 100 ones is really 10 tens, which is really 100. Now let's talk a little bit about 11 and 12. When we think of the word 11, it actually comes from the Old English word enlofan, which means anlif, or one left after 10, which really does make sense. And for 12, it comes from the Old English word twelfth, or twalif, which is 2 left after 10. So as it turns out, there's a lot of logic to our base 10 place value system. Where there might not be as much logic is the English words we use to name certain numbers, like 11 and 12. So let's make sure our youngest learners are aware of the meaning of each number instead of getting too hyper-focused on memorization without meaning. So here's my last little tidbit to take with you as we come to the end of this Fundamentals of Mathematics video. Let's look at 228. When students are engaging in purposeful practice with place value, you might hear questions from teachers or practice problems from textbooks and worksheets that ask questions like, how many tens are in 228? Unfortunately, the answer many textbooks and worksheets are hoping for is 2, since the digit 2 is placed in the tens column. However, that is the answer to a more specific question, something like, what is the value in the tens column? In that case, the answer is clearly 2. However, if the student has a conceptual understanding of how place value works, they should recognize that while place value shows us that there are 2 tens in this number, thinking of place value alone, in reality, there are many more tens that exist in this number. By asking the question, how many tens are in 228, we are really asking a division problem of 228 divided by 10 squares per part, or per group. And we can model this using base 10 blocks that there are 22 tens in 228 with 8 ones left over. Or you could also say that there are 22 and 8/10 tens in 228. Whoa, did you see what we just did there? We just did some fractions just like that. But don't panic. We're going to unpack fractions accessibly from the ground up in the next video. So for now, let's just use a notation that we're all likely familiar with, and that leverages place value, which is 22 decimal 8 remembering that that 8 is in the tenths column, 8/10. Who knew that place value was so complex and so important for our mathematical understanding? I hope you enjoyed this Fundamentals of Mathematics video where we focused on the importance of place value. We'll see you in the next video where we're going to move from working with whole numbers to working with fractions. We'll see you then.